welcome back everyone to the Hello World Guide. This is another episode of the Asteroid game in C++ series, and in this video we are going to continue with the functionality for our Asteroid game by implementing the asteroid so that it can have different directions and also can alter its direction once it reaches the edges of the screen. And the latter thing we are going to do first. So first of all, let's go up on the top here, and where we have got all of our constants, we are going to define two more constants here as player width and player, well, we are going to copy that, but we are going to rename this to asteroid width and asteroid height, and we are going to use this because we want to, of course, kind of find out when the asteroid has gone out of the screen, and for that we do need the width and height variables. And let's go down here in the asteroids update function. In here we can just say an if statement: if our position dot x, the asteroid's position, is less than our asteroid width by 2. And notice that we are not just clamping. So if we want to actually change the direction, if it hits not clamp it, and otherwise we are basically using the same values here like we have got here. So if you don't know, you can watch the previous video to kind of understand how this is supposed to work. So if that is the case, we are going to set direction.x is equal to the absolute value of direction.x, which means it is going to be positive. Now you might be wondering that if it is going towards that direction, it probably means that it's going in the reverse direction. So why should we actually invert? We could just say negative direction.x, but that will actually not work. And the reason for that is that if it, for example, for some reason our frame rate drops and then it stays there for 2 frames, then it would get stuck in an infinite loop where it would be constantly inversing the direction and nothing would work. So we need to make sure we set it correctly, and for that purpose I'm going to use the absolute value. If that is not the case, we are going to check if the position.x is less than screen width minus asteroid width and not actually less, greater than. If that's the case, we are going to set its value to be negative, which means it's going to go here, its value is going to set to positive, it's going to hit this point, and then its value is going to set negative and it's going to go back. And that's just copy that, and similarly for the y, we are going to change the width to the height here for everything, and position of y as well, and that is all we need to do. Yeah, that is pretty much all right. And now we need to make sure we set the correct values, and the correct values, I just you can kind of look at the coordinates of the asteroid points to find out that the axis aligned bounding box should be width should be 90 and the height should be 80. Of course, if you've got a different shape for the asteroid, you need to figure this out on your own. Now that works, but the next thing I'd like to do is that I would like our asteroid to have a random initial direction. Before we do that, let's just run this and see if our inversion system actually works or not. And what you should see is that if I run this, yeah, you can see it goes towards the left, and once it hits the screen it goes towards the right now, and it does seem to work correctly. And let me just, to test this better, let's just go up here and, for example, set the speed to, I don't know, let's set it to 280 so that we can kind of see it better without having to wait a long time. And what you should see is that yeah, it hits this and then starts going in the other direction, and as soon as it hits that point it starts going back to this direction, and you can see that that is working. Now let's also test it on the vertical direction. For that purpose I'll go here and change this to 0 and change this to 1 to kind of just manually change the direction to be vertical, and let's run that, and now hopefully we will get that working as well. So actually we might not get that working correctly. You can see that it goes a bit off screen, and the reason for that, if I'm not wrong, is that yeah, we need to be using screen height here, not screen width, so use screen height. And let's run that, and what you should see is that now the y-axis is also working correctly. Yeah, you can see it goes down, it hits this, goes back up until it hits that point, then it starts going down again, and it's all working quite well. So yeah, that's all pretty awesome. And now the next thing that we need to do is we need to figure out a way to initially put a random direction for the asteroid so that it's not always going in a single direction and every asteroid is different. So we need to figure out a way to calculate a random direction for the asteroid. So in order to ensure that we have got a random direction, we are going to go ahead and create a static function inside of the asteroid class, which is going to return a vector2 called getRandomDirection. And when we are creating a new asteroid, we are going to just utilize this function, asteroid getRandomDirection. And for the random direction, now for the actually calculating direction with an x and y component, it's going to be a bit difficult because we'll also need to normalize a vector and whatnot, which as a vector does not support. We'll need to use a more complicated math class or something. For that reason, we are going to not do that. Instead, what we are going to do is we'll first create an angle called just a float called angle, which we'll randomize actually, and then we'll return a vector from that angle by calculating the cos of the angle on the x and the sine on the y. Anyways, that should give us the x and y component correctly, like we have been doing that in the player as well. So yeah, that's going to work, and we'll need to calculate this angle randomly and in gradients also. So for that, we are going to use the C++ random library, because that's going to be a bit better. We'll create a random device. Of course, you'll need to actually include random up here, so make sure you include random up there. So here you need to have included the random library. Anyways, let's go down and create a stdm19937, whatever that is, which is a random engine, and we need to initialize it with our random device. And then we'll need to create a std uniform real distribution, which will pass float, because we don't want a double distribution, like we are just using a single precision float, so we'll pass that. And we will create a distribution of 2 0 on as the minimum, and the maximum value is going to be 2 multiplied by pi, which is what the maximum radian is. So in radians, there are actual rotation goes from 0 to 2 pi. And with that, we can just, for the angle, we can just calculate it by saying distribution and calling it, and by passing the argument of our engine. And by the way, these brackets do not mean this is a function. It just means that it's calling the random device operator function. So this is like you can overload the function call operator as well. So that's what it basically is doing. And then we'll set our angle to that, and now let's test this and see whether it works or not. Hopefully it should work correctly. If I run this, what you should see is that as soon as I run that, you can see that well, our asteroid went in that direction, which was randomized, and if I run it again, our asteroid should go in a completely different direction. You can see it goes in a different direction, and each time I run a program, the asteroid will actually go in a different direction, which shows us that this system is working. So yeah guys, this is pretty much it for this video. I'll see you in the next one, in which we'll start implementing the actual first of all, a system for spawning more asteroids than just a single asteroid, and then we'll get started with the physics implementation of when we shoot the bullet, they should collide with the asteroids, and the player should collide with the asteroid as well. So we'll do that in the next video. Stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and bye.